All right, for 7.7, let's talk about the real world examples and where you will see these types of exponential equations, where you will see e, where you will have to use logarithms to solve, and it's primarily when it comes to calculating interest. So if you're planning to take any upper level business classes, anything like that, you need to be familiar with this type of formula. Now we're going to write the formula out together, but on the test I promise I will give you the formulas and you just have to know which of the two formulas to use. So our first one is this one. It does, doesn't it? We're at the point now where it does. Just go ahead and write it, and we'll start talk through it.
If you were to tell me that I was gonna learn this in kindergarten, like if I was in kindergarten,
Why would we want to overwhelm a kindergartner? No, don't worry about it. All right, so you walk into a bank, right, and you want to figure out how much money is, if I'm depositing $1,000, how much money am I going to have after a certain time period? So there's certain things we have to know, right, about how like banks work. First of all, an interest rate. What is an interest rate? What does that even mean?
The amount of money that
they pay you, right? They want your business, right, and they're going to be investing it for you. And right now, what are interest rates?
0.3.
Horrible.
Yeah.
They're really good if you're borrowing money, right? Which is why our stimulus package might go through, because the government can borrow $1 trillion right now. Interest rates are so low. But that's not really good for investors. That means you're just making a few pennies back. It's not great. That's why people turn to the stock market or other investments, because right now interest rates are not very high. So that's what an interest rate is. Principal is the amount of money that you're depositing into the account. N is the number of times a year that your interest is going to be compounded. So how many times are we going to calculate your interest and then reinvest that money? So you may start with $1,000, you only make $3, but if they're reinvesting that $1,000 and now $3, right, it's important to know how many times a year they're reinvesting that money of yours. And then the time is always going to be the number of years, right? Because you want to know, if I'm depositing $10,000 in my savings account, when can I retire with $1 million, right? These are the things that people care about, and this is what the calculation that banks use to figure this out. So let's look at our example here. You deposit $1,000 in an account that pays 7%, woohoo, annual interest compounded semi-annually. What does semi-annually mean?
Every 2 years?
Twice a year. So we're going to start filling out. And if you ever have a question on vocabulary, right, that's definitely, feel free to ask me, right? I know that these terms are kind of new for us. Now, interest rate, I can't write it as 7%. I have to write it as a decimal.
0.07.
Yep. We know the principal that we're going to be investing is 1,000. And the amount, right, I'm trying to figure out how long is it gonna take to get up to $1,500, right? I wanna make some money. Anybody have a guess before we start solving this? How many years is it going to take for you to make $500 on an $1,000 investment?
13?
7% interest, pretty good.
My guess is 13 years.
13 years?
4.
4. 10. Let's see what we get.
Mine's like, let me go median.
Well, but at least nobody threw out 1,000 years, okay? We all at least can realize we're going to get there. It might take a little bit, but let's get there. So I'm going to plug this into my formula. So 1,500 is the amount that I want to get. I have 1,000 that I'm putting in. 1 plus 0.07 divided by it's being reinvested semi-annually, raised to the 2t power.
Time, child, grandfather died.
Right, that's what we're trying to find. We want to find t, the time in years, right? We'll get a decimal answer, but we'll be able to round. So yes.
So we have to take 0.07 divided by 2 first.
That's what I first would recommend, right? Basically, order of operations tells us that within the parentheses, I have to do the division before I add 1 to it. So yes, let's go ahead and do all that. So I do
Yeah,
0.07 divided by 2, and then I add that to 1. Did everybody get 1.035?
Yes.
Anybody have any questions on that? Now, I want to isolate the thing that's being brought to the exponent.
Divide by 1,000.
Yes,
Goodness.
I know. This is the problem with real world examples, right? They're not always pretty numbers.
Oh, no kidding.
1.5.
So I get 1.5 is equal to 1.035 to the 2t power.
What did we, square root it by 2t?
Unfortunately, we can't. The reason being, right, why have we started learning about logarithms? If my exponent
No.
is
Oh,
the
God.
variable, I'm going to have to use logarithms to solve. Right? Well, you know,
Don't get encouraged.
if we could figure out how to write, 1.5 as a base of 1.035 and figure out what power it's raised to, but we can't do that, right? That's what we did last class, and we can't do that when we're working with decimals. How do I write this as a logarithm? What is the base of my exponential equation?
2t.
What is the base?
10?
1.035.
So here's the thing, right? Normally, our base, like when we write an exponent, right, we write like b to the x equals y. It's on the left side of my equal sign. Now it's on the right side. So I circle my base, come around the other side, and now I've got to circle all the way back. So it really is just because of the way we've written it, our exponential equation is a little bit backwards from what we're used to.
Okay.
So I get the log of 1.035 of 1.5 is equal to 2t.
And then we have to, I don't know. Divide by 2? No.
We will eventually have to divide by 2, but can I pick up my calculator and put in a base of anything I want?
No.
Yes. No.
But
Oh.
what new rule did we learn at the very beginning of class today?
Just put it back.
Something x base x b equals something b over something x.
Close. What we learned
Log base b x equals
is
log
right
x over
here,
log b.
right? That thing, maybe we should put a star around it now in our notes. That base change rule we're going to have to use so that we can type all of this into our calculator. And I'm running out of space. So let me just...
Like, we just go bleep. Don't look at me like that. This one.
So using our base change rule, we wind up with the log of 1.5 divided by the log of 1.035 is equal to 2t. So now I can pick up my calculator and try to figure out what this value is on the left-hand side of my equation. So go ahead and make sure, right, you've got parentheses around these. I got 11.76. Everybody agree with me? Oh, I got 11.79.
Yeah, 7-9 is
Yep.
better.
I gotta make sure I write my notes clearly. So now what do I do?
Divide by 2.
Just divide by 2. So the time in years that it's going to take, let's still round to 2 decimal places. Time is about 5.89 years before your account has made $500.
A little under 6 years.
A little under, yeah, but this is estimating, right? So
By the
it's going to
time you
take
get-
6 years for your bank account to make $500. Not too bad if you can find an account that's paying out 7% interest semi-annually. All right, we're going to do one more word problem. You guys are doing great today. I know it's a lot. Right, this whole equation that I had us enter, where you were like, that's the whole vocabulary, right? Yeah. If you remember back to the very, very beginning, when we started 7.5 and we got introduced to the letter E, it kept saying that this part of your equation just keeps getting closer and closer to E as your numbers go up, as you approach infinity. So what a lot of banks use is they're going to use a shortcut. They're going to replace all that middle letters with just the letter E. Because what the banks do, right, they're not going to just say, well, we're just going to put your money in an account and then every 6 months we'll look and see and we'll add some interest to it, right? What banks are doing is they are continuously reinvesting your money every day. Even if it's fractions of a penny, they're reinvesting that money for you. So whenever you see the word continuously compounded, you are going to use this formula. So if you see the word continuous, right, ding, 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 you are going to use this formula, and again, I'm going to give you this formula on the text. Let's see, which one? Let's look at example 2. It's a little bit more interesting than cameras.
Oh, hello.
So example 2, you deposit $800 in an account that pays 2.65% annual interest compounded continuously. So I saw the word continuously. What is the balance after 12.5 years? So we've got our PE to the RT, PERT. What is our interest rate?
2.65.
Which I have to rewrite as a decimal.
0.2.
0.0265. Because I've got to move my decimal over 2 places when we're talking about percentages. What is the time? They give us the time. 12.5. This one's going to be a little bit easier to evaluate. And I'm depositing P, $800, into the account. So I get to find out what the amount is, meaning I'm just going to evaluate this problem, making sure, let me make sure I write this clearly. So I have 800 times E to the 0.0265 times 12.5. So I can just pick up my calculator and type all of this in. Remember, E raised to a power is second natural log. And make sure when you have E to the power, you're putting 0.0265 times 12.5 all in that exponent there. I got out $1,114.17.
Okay.
Rounding up. Questions there? All right, so that concludes 7.7. Your homework assignment is the 7.7 worksheet in your packet.